Discuss what happens when you connect an inductor across a battery E. So if the EMF is E and here the inductor is L, we know that phi is equal to L into I. So EMF, if you want to find out this value, the induced EMF here E will be exactly equal to the applied EMF but in the opposite direction. So but EMF can also be given as from this relation E equal to d phi by dt. So d phi by dt with the negative sign. So in the same way, if an inductor is connected across an alternating EMF E given as E naught sine omega t, this inductor is L. So we know that EMF is equal to minus of d phi by dt, and the applied EMF, and this EMF will be opposite to this. That is why that minus of minus d phi by dt is the applied EMF. So d by dt of phi is equal to Li, L into I, instantaneous current. So EMF is equal to L into di by dt, which means that di is equal to E by L into dt. So di is equal to E is E naught sin omega t. So E naught sin omega t dt by L. So I is equal to integral of this E naught by L. Integral sin omega t is minus cos omega t by omega. So then minus E naught by L omega into cos omega t can be written as sine of 90 plus theta. So that is pi by 2 minus omega t. So sine of minus theta is minus sine theta. So when the sine goes up, so E naught by L omega sine of minus of pi by 2 minus omega t. So you're getting E naught by L omega. So this L omega is equivalent resistance offered by this. Let us call inductive reactance. So inductive reactance XL is nothing but the resistance offered by the inductor when current flows through it. Okay, XL sine becomes cos, sine of omega t minus pi by 2. So let me write this here. I equal to E naught by XL is the maximum value of current to sine of omega t minus pi by 2. If you look at this, we applied E equal to E naught sine omega t, whereas what we got as current across inductor when we connect, the current is I naught sine omega t minus pi by 2. Here it lags, so it is sine omega t, this is sine omega t minus pi by 2. So current lags behind voltage, by pi by 2 radian or 90 degree in only inductor circuit. Here I naught is given by E naught by XL, and XL is nothing but inductive reactance, that is L omega. Okay, E naught by L omega. Suppose if you draw the same way we did for in resistor and capacitor, if applied EMF is drawn like this, then this is equal to E naught to minus E naught, but the current here is lagging behind. By the time this is 0, this is 90 degree behind. So when this maximum, when this becomes 0 and 0, when this becomes 0, that time only it reaches the maximum, and then when this is 0, my negative maximum, this is 0, when this is 0, this is reaching the negative maximum. So current will be like this. So it is somewhat like this. It started 90 degree behind, so that is why it goes like this. Okay, so the same way if you draw phasor diagram, and if you draw the applied EMF E here, or EMF E here, and the current lags behind 90 degree. This is E and this is I. Or you can also draw something like this. Suppose if you draw EMF randomly here, if you draw EMF here E, the corresponding current will be like 90 degree behind. So this is instantaneous current.